In this video, we're going to talk about the addition principle. So we use the addition principle when we can break a problem down into what we call cases. So this is where it's a different type of way to break down the problem. So different than the multiplication principle. So here, you think of a problem, so you want to count something, and there's different ways in which it could occur. So you're not building up like we are with the multiplication principle, where to complete this task I have to do task 1 and then task 2 and then task 3, and so I want to multiply those. Here we have a task that we could do in this way or in that way. So there's two different ways that it could happen, where they can't both happen at the same time. So it's either the first way or the second way, but not both. This is the idea behind a case. And when we can break the problem down like this, we use the addition principle, or that's sometimes referred to as the rule of sum. So I'm going to give you the principle first. So if there are m choices for one action and n choices for another, and the two actions cannot be performed at the same time, then there are m plus n ways to choose one of these actions. Okay, so we're only picking one of them to happen. So that's the idea. Again, as with the multiplication principle, this can be generalized to more than two cases, but I'm not going to write the generalized version. Hopefully we can get to that by an example. So what I want to emphasize here, remember when we multiply, you generally find yourself saying something similar to and then. I'm going to do this, and then I'm going to do this, and then I'm going to do this, trying to accomplish one goal. Here, you want to add when you're thinking something like this or that, but not both. Something like of that sense. So I think this will be more clearly illustrated with an example. So let's just do one. We're not going to need the addition principle right away. So we're going to get an idea of what's going on here before we build up to when we need the addition principle. So suppose we toss a coin 8 times and record the results. Okay, so one type of result we might have is heads, heads, tails, heads, heads, tails, tails, tails. Okay, I think that's 8 flips. Okay, so we would record something like this. This is one result that could happen. So how many different records are possible? How many strings are there that look like this with only using heads and tails? So the way we could do this is we could break it up by flip. 1, 2, 3, 4, 5, 6, 7, 8. So this is flip 1, flip 2, 3, 4, 5, 6, 7, and 8. So now for each flip, there's 2 options. Okay, so it's either heads or it's tails. So I have 2 options for each of the flips. I can have repeats, so there's 2, and I'm going to multiply all of these guys because I have to do each of the flips in order to get my record. So this is 2 to the 8, or 256 different records. Now, how many of these records contain exactly 2 tails? So this can be a bit confusing. So let me try and illustrate this. 2, 3, 4, 5, 6, 7, 8. Okay, so here's our 8 flips. Now I want exactly 2 of these to be tails. So how I could do that is it would be useful if I knew which 2 were tails. So what I might want to do is select. So maybe we select which flips are tails. Okay, so what that means is we're going to select 2 of these spots. Okay, maybe here we pick the flip 2 and flip 4. So how many ways are there to select 2 of these 8 spots or 8 flips? Well, the order doesn't matter because they're both going to be tails. There's 8 flips, okay, and we want 2 to be tails. So what we're going to do is from the 8 flips, select 2 of them to be tails. So suppose we pick 2 and 4. How many ways could those be tails? Well, I've picked them to be tails, so they have to be tails. There's only one way for them to be tails. So I'll put another line here. So another thing we can do, so make these tails. So the 2 that you select. So there's only one way to do that for each. Now, the rest of them have to be heads. Remaining 6 spots or flips must be heads in order to have exactly 2 tails. Okay, I don't want more than 2. So that means that I have only one option for those other 6. Okay, so these have to be heads. Once I know where the tails are, everything else has to be heads. So in fact, all I have to do is select where the tails go. So 8 choose 6. Sorry, 8 choose 2. But this is the same as 8 choose 6 because we could select, this would be select where the heads go. Okay, it's doing the same thing. So both of these are equal to 28. So there's 28 different records that have exactly 2 tails. Now, here's where the addition principle comes in. How many of the records contained at most 2 tails? Okay, so at most means that they could have 0 tails, 1 tail, or 2 tails. So here, there's 3 different ways that we could satisfy the record. There's 3 different ways that they could happen. Now, none of these can happen simultaneously. So either we get 0 tails, or we get 1 tail, or we get 2 tails. Those are the only ways where we get at most 2 tails. So we want to count how many ways each of them could happen, and then we're going to add. So these are 3 different instances that we get at most 2 tails. Now the reason we want to split it up like this is it's always easier to count when you know exactly what's happening. Okay, so the number with at most 2 tails, I'm going to use shorthand like that, so less than or equal to 2 tails is going to be the number with exactly 0 tails plus the number with exactly 1 tail plus the number with exactly 2 tails that we already counted. Okay, now the other ones are counted similarly. So when we want 0 tails from the 8 spots, we want none of them to be tails. Okay, this is actually a 1. So this makes sense because this is the flip where they're all heads. There's only one way to do that. Now, when we get exactly 1 tail, we're going to pick from the 8 spots, 1 spot to be tails. So this is 8. And then the exactly 2 tails we already did was 8 choose 2, and we know that this is 28. So let me just try and justify this one. So the 8, so we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 spots where the tails could be. So once we pick a spot, say that's tails, everything else has to be heads in order to have exactly 1 tail. So there's only 8 spots where we could put that T, so there's only 8 different ones. So here, the total is 37. So there's 37 different records that have at most 2 tails. So you see how it breaks down like that? There's a couple of different scenarios where the thing that we want to happen happens. So we want to look at these individually and try and count them individually. So you want to remember when you're doing problems that it's easier to count when you know exactly what's happening. So often when you see at most or at least or less than or more than, cases are going to be something you should have in mind. So let's do one more example. So suppose I have 5 shirts, 3 skirts, and 12 dresses in my closet. So that's 20 items total. Okay, and I want to give away 5 items. So in the beginning, I would just want to know how many ways could I grab 5 items to give away. So we have 20 items, and we want 5, and we're just going to give them away to some charity. So they're all going to the same place. So the order doesn't matter. Okay, so I want to use a choose. So this is of the 20 items, my 20 clothing items, I just want to select 5 to give away. So I'm going to do 20 choose 5. This happens to be 15,504 different ways. Okay, now I still want to give away 5 items, but I'm willing to part with at most 1 skirt. So that means we can give away 0 skirts or 1 skirt. Okay, so at most 1. So only 0 or 1. So I want to split into these cases. So the number that gives away at most 1 skirt is going to be the number with 0 skirts plus the number that gives away 1 skirt. And we're still giving away 5 items. So when we count 0 skirts, I should have done 1 first, but okay. So we're going to pick skirts to give away, and then we're going to pick other items. So here, we don't want to give away any skirts. So how many skirts do we have? We have 3 skirts. So from the 3 skirts, I want to pick none. Okay, from the other 17 items, I want to pick all 5 items to give away. Okay, now same idea over here. So from my 3 skirts, I want to give away exactly 1. So I pick one of them. And then from the 17 other items, I want to give away 4. So 17 is 12 dresses and 5 shirts. So I don't care if they're dresses or shirts, I just want to pick 4. Okay, they might all be shirts, they might all be dresses, who knows? So if I compute these, I get 6,188 plus 7,140. So this is 13,328 in total. So that's the number of ways I can give away 5 items, guaranteeing that I give away at most 1 skirt. Okay, another one. So here I still want to give away 5 items, but now I want to give away at least 1 dress. So how could I give away at least 1 dress? So it means I could give away 1 dress, 2 dresses, 3, I'm going to call them Ds now because I am running out of room, so 3 Ds, 4 Ds, or 5 Ds, because I have 12 of them, so I'm not going to run out, and I want to give away 5 items. So the most I can give away is 5. So we'd have to split into these 5 cases. So that means the number with at least 1, so bigger than or equal to 1 dress, is going to be the number with 1 dress plus the number with 2 dresses plus the number with 3 dresses plus the number with 4 dresses plus the number with 5 dresses. And I'd have to do all of these cases separately. So in case 1, 1 dress. So from my 12 dresses, I want to pick 1. And then I need 4 more items from the 8 other items. So I'd have to multiply by 8, choose 4. So in each case, so this is sort of one case, I still need to give away 5 items. So I need these numbers that I choose to add to 5 each time. Okay, so 2 dresses. Oops. Let's go back to purple. So 2 dresses. So from my 12 dresses, I want 2. And then I need 3 of my other items. Notice these add to 5. 3 dresses, so from my 12 dresses I pick 3. And now I need 2 other items. So again, add to 5. So now I have, from my 12 dresses I need 4. From my other items I just need 1. And then lastly, from my 12 dresses I need 5, and if you want, you can keep the 8, but now we're choosing 0. So again, these pairs always add to 5. So if we add these up, I wrote them all down. So this is 840 plus 3,696 plus 6,160 plus 3,960 plus 792, and you get 15,448 ways. Now, this was a lot of cases. Normally, my limit is 3 usually, so if I have to do more than 3 cases, I'm a bit wary that maybe there's a better way to do this. So here there definitely would have been. We mentioned this earlier, but it's a method called counting the complement. So the idea is when something is hard to count, or has many cases. Okay, maybe the cases are all easy, there's just lots of them like there was in the previous part, or has many cases. It may be easier to count the complement instead. Okay, so remember, we had the number of things in A, some set, is the number of things in the universe minus the number of things in the complement set. Okay, so if A is hard to count, sometimes counting the number in the universe and subtracting the number in the complement is actually easier. So had we done 2C this way, the number in the universe we already counted. Okay, so this was give away 5 items, which was 20, choose 5, so 15,504. And if A is, I'm going to use sort of bad notation, but at least one dress, then A complement is the opposite. So if we don't have at least one dress, it means that we have less than one dress, which means that we have 0 dresses. So we don't give away any dresses. So notice there's only one case here, only one thing to count. Okay, so the number for A complement, or the number with 0 dresses, is going to be 12, choose 0, so choose none of the dresses. 8, choose 5, so choose all 5 things from your 8 shirts and skirts. And this number is 56. So then the number in A, our set, so this is the number with at least one dress, is going to be the universe, so 15,504 minus 56. And if you do that, you get 15,448, okay, which is the same as we got up above. But notice it required a lot less work. So if you are finding that you have lots of cases, and by lots, usually for me that means more than 3, then you might want to stop yourself before you plow through and think, what does the complement look like? Because it might be a lot easier. So that's an introduction to